we will discuss the decoder, and then we will discuss the implementation of a Boolean functions with the help of a decoder. The first we come to the decoder. To explain the decoder, I have taken a 3:8 decoder. In that case, there will be 3 inputs and there will be 8 outputs. And in a simplified manner, we can say the decoder is very similar to the demultiplexer. And with a difference that in the case of a decoder, there is no input. The select in the case of a demultiplexer are the inputs in case of a decoder. Now, in this case, particularly in this case, we have 3 inputs. Therefore, the number of outputs we can calculate. It is 2 to the power of 3 and equal to 8. There are 8 outputs. And then, out of 8 outputs, one of the output will be high and the remaining output will be 0. And which one will be the high output? It depends upon what the inputs value we assign to the ABC. Let us take an example. If A equal to 0, B equal to 0, C equal to 0, the Y0 will become high and the remaining Y1 to Y7 will be 0. In a very simplified manner, I can say that if we take A as a more significant and C is the least significant, then we put a binaries and then we have to convert into the decimal, and the decimal subscript, whatever we get the decimal subscript, that will become the high. As for example, if A equal to 0, B equal to 1, C equal to 0, therefore decimal equivalent is 2, and then Y2, output Y2 will become high and the remaining all will become 0. Another example I will take, that if A equal to 1, B equal to 0, C equal to 1, and the decimal equivalent is 5, and then Y5 will become high and the remaining 7 will remain low. That is in a very simplified way, we can say in that way. Another way we can see that the Y0 is becoming high when A equal to 0, B equal to 0 and C equal to 0. It means that it is high. We can write the expression for that. Complement of A into complement of B and complement of C. And complement of A will be equal to 1 in that case. Complement of B will be 1 and complement of C 1, and that will be high. And this is the mean term, that is also M0, that is represent M0. In that way, the output of Y0 is nothing but M0, output of Y1 is M1, Y2 is M2. In this way, an output of Y7 is M7, is a mean terms. Therefore, we can implement in that way. If we come to the implementation of a particular Boolean functions, what is given here, and that Boolean functions is, if I express in this Boolean function, is nothing but this is a 3 variable Boolean functions, and therefore this is, I can write in this form. Therefore, M1, M3 and M7 is nothing but this. And therefore, I want to implement this because this Boolean function to be implemented in this decoder. Therefore, I want to explain why you have drawn the circuit here. Therefore, this is the expression for these Boolean functions. And you can see that if we prepare the truth table, if any one of these, this is the summation of the products. Therefore, any of the terms become 1, output will be 1. And therefore, if any other cases, the output remains the 0. Therefore, we can see this is the mean terms here. I have taken this is the min term, here it is, this is representing M1 and this is representing M1, and this is representing M3, is representing M3, this is representing M7, this is the M7. Any one of them, that means M1, M3, M7, any of them is high, then output will be high. Therefore, we have taken the that is the OR, that is this is the M1, and this is the, you can see this is the plus sign is there. Therefore, you have to use the OR gate. Therefore, this is the circuit I have drawn here. This is the M1, this is the M1, this is the M3, and this is the M7. And summation of this, you can exactly same expressions. Because of the summation, we have to use the OR gate. Any of them is 1, therefore output should be 1. And therefore, this is the implementation of the Boolean functions with the help of 3:8 decoder. And we have taken the 3:8 decoder because there are 3 variables. In the case of a 4 variables, obviously we have to take the 4 variables decoder. Now, the other Boolean functions, exactly the same logic, and therefore we have to summation of the M2, M3, and M5, and therefore this is the M2, M3, and M5, and we have used the OR gate because this is the case of it is the case of a summation of this, and any of them is 1, therefore output will be 1. Therefore, this is the implementations of the Boolean function with the 3:8 decoder. Now, in the case of a decoder, another thing I want to mention here that here this decoder I have drawn, it is completely from the basic fundamentals, the definition of the decoder. But in case of if you come to the decoder IC, what is available in the market, if one of the is 74138, in that case, it is a difference from that. What is the main difference is that all the output in that IC are get complemented. Therefore, one of them in case of an IC, one of them will become low, and remaining all of them will become high. As for example, if A equal to 0, B equal to 0, and C equal to 0, in this circuit, that is meant from which I discussing from the definition of the decoder, Y naught will remain high and remaining will become low. That I told you. But in case of a 3:8 decoder IC 74138, one of these output will remain low, remaining will become high. Therefore, in case of A equal to 0, B equal to 0, C equal to 0, Y0 will become low and remaining all will remain high. And because they are complementing each of the output, and that difference should be taken care of. And if this Boolean expression is asked to implement by IC, in that case, the circuit we have to complement each of them. That is very easy to do it if we use the IC. Therefore, obviously, because the IC is complementing, we have to further complement, get it in the original forms. And I think it is easy to do it. Nothing to do, only to do the complement of it, because the IC is complementing each of the output. That I wanted to mention here.